Hello, everyone. My name is Megan Duvert.
Hello, my name is Kiersten Palanek, and I will be discussing some methods used to refine Jaguar home ranges.
Researchers in jaguar ecology have traditionally relied on camera trapping to study their behavior and ecological dynamics, but this method's limitation in capturing detailed spatial data presents a significant challenge. To overcome this, integrating GPS collaring with camera trapping emerges as a promising solution, offering a more comprehensive and accurate assessment of jaguar home ranges. This approach provides researchers with nuanced insights into factors influencing habitat selection and movement patterns, facilitating more informed conservation efforts.
The first method you could use for camera trapping is placing cameras in areas where jaguar signs have been observed on trails, roads, and ponds. One pro for this method is it provides preliminary information on the presence of jaguars at a given site, as well as confirms the use of particular locations. Some cons of this method are it does not coincide with Jaguar estimates from systematic surveys, and there is more possible bias.
Another method you could use for camera trapping is placing cameras systematically. So, for example, you can place a single camera or two cameras that take pictures simultaneously, a certain distance apart along roads and trails in your survey area. And a pro of this would be that you can maximize your chances of photographing a jaguar. And with the number of photographs that you get, it could positively correlate to species density, and the capture frequency can serve as an index of relative abundance. And placing the camera systematically can cause less bias for your study. A con could be that you're unable to identify factors that would increase the likelihood of jaguars visiting those spots, and it doesn't always translate into species density when it comes to the capture frequency, only because of bycatch, so you have to take that into account. And then with setting up a grid, you will predetermine spots that you are putting your cameras in, and once you arrive to those spots, there may not be an open clearing, so you have to create those clearings or those trails to get to those cameras, and you have to make sure that you maintain those throughout your study so that there is nothing obstructing the view of the camera.
The last method for camera trapping is a combination of both methods above. Some pros for this are it is non-invasive, it produces statistical estimate with only 2 or 3 months of trapping, it allows for round-the-clock surveillance, and it can be deployed for extended periods, facilitating long-term studies on population trends, seasonal variations, and responses to environmental changes. Some cons for using both methods is it can be expensive, such as the cost of cameras and batteries, the large number of traps required, and the investments in trails where road or river networks do not exist. Some more cons are that bycatch adds to the number of files to review. Jaguars can be in the same area as the cameras but can never trigger it. And finally, cameras give an idea of the displacement of the animal, but not the total distance traveled.
Another effective method to track animals can be through collars in the form of Global Positioning System, GPS, or radio telemetry. With GPS, they could be pretty customizable. You could customize the amount of data points that are taken, when they're taken, and for how long they're being taken through each day. So, for example, you can set the collars to take 40 data points at dawn and dusk for 3 hours each day. Another pro is that GPS can provide an estimate of spatial use, and it can help document the social interactions between individual animals. Jumping to point 4 in this pros list, GPS collars allow for the simultaneous capturing of locations of multiple individuals within minutes of each other. So you can kind of see how they interact with each other in real time. Another pro for GPS is that it will require less field time because with the collars, you could store data points on the collar, and you could also have the option to remotely download your data points. For cons for GPS, with dense vegetation such as forests, you could have issues with signals being blocked to the satellite. And in general, GPS collars tend to weigh more and they have a limited battery capacity.
Another method is radio telemetry. Some pros of this are that it has better battery life than GPS, and the steadiness of the signal indicates a type of movement. Some cons are that you must physically find the Jaguar to collect the data, and the body movements, dense vegetation, and harsh weather can block signals. And finally, another con is it provides less precise location data unless you are in close proximity to the Jaguar.
Overall pros when it comes to using collars, whether that is in the form of GPS or radio telemetry, is that collars can provide spatial and temporal location in small time intervals and in long distance tracking. This enhances the completeness and accuracy of home range assessments. There are also many settings for collars that can tailor study designs based on the needs of the research, and the settings can also help to optimize battery usage, especially when GPS and telemetry are used together in one collar. These settings and the use of both methods can also help to optimize cost, for example, using GPS for high-resolution tracking periods and radio telemetry for long-term monitoring. Because placing collars on jaguars requires sedation, it is easy to obtain accurate descriptions of the animal's body condition, their sex, and age. Overall cons with either method can be that it could be costly. This includes purchasing collars, the equipment used for capture, such as trainers, dogs, dart guns, and medication for sedation. Collaring is also invasive. It requires physical contact with the animal and an attachment to their body. It can pose a risk to the animal and to the researchers involved. It may take at least a year of research efforts to determine home range, and collars can malfunction, whether that be from collars suddenly dying, falling off, or other technical issues.
Integrating GPS methods with camera trapping for wildlife monitoring is limited in literature, thus hindering the comprehensive exploration of their combined efficacy and potential synergies. Based on the pros and cons found in this review, the suggested method to best define home ranges of jaguars would be to combine GPS tracking with systematic placing of cameras. The amalgamation of GPS collars with camera trapping not only enhances the accuracy of home range assessments, but also offers a more holistic perspective on jaguar spatial ecology. This approach can provide researchers with a nuanced understanding of the factors influencing jaguar habitat selection and movement patterns.